Well, Pete, it's October now and the nights are getting longer, and we should start off with the inner solar system. And Mercury, this reaches greatest eastern elongation on the 1st of October, and that sounds like it should be quite prominent in the evening sky, but unfortunately it's not. It's really rather low down.
It's interesting, isn't it? You get some elongations where the planet is really well placed and others where it's not, and this just is not very good. But its outer solar system neighbour, I guess, Venus is actually pretty well placed, but you have to wait until the morning sky to see that. It's pretty spectacular, passing east through Leo for much of October before finally ending up in the bowl of Virgo at the end of the month.
Yeah, it's really quite striking just how bright it is in the early morning sky. It took me by surprise the other night. I was observing Mars, actually, and the bright beacon of Venus was suddenly there. I thought it was an aircraft landing light to begin with. Of course, it didn't move. And then a telescopic view revealed it was the planet Venus. So, yeah, it's incredibly bright.
Yeah, it is incredibly bright. On the 3rd of October, it appears really close to Regulus in Leo. So that's something to look out for, because there'll just be 12 arc minutes apart on that morning, which is pretty close, isn't it?
It is pretty close, so it'll be a nice photographic opportunity. Well, moving further out into the solar system, I guess the planet of the month, maybe even planet of the year, certainly is in my case, the planet Mars, comes to opposition in October. In fact, its opposition occurs on the 13th of October, and this is when a outer planet, is best seen because it lies on a line with the Sun, the Earth, and the planet all on one line, and the planet is best presented in our night skies at this time.
Yes, it is. It actually, it's closest to Earth on the 6th of October, and that's when it'll be at its maximum size. But we should point out that when we're talking about, the opposition time, which is 13th of October, and the closest point, 6th of October, they're not instants in time. Mars doesn't suddenly get really good and then not be very good. There's a whole run-up to it. I mean, we've had a brilliant run-up to it since really July time. That's when it's been pretty good, isn't it?
It has, yes. I've been following it really since June, July, and we've had some fascinating things happen. We've had some small dust storms near the South Polar Cap. Mars' southern hemisphere is tilted towards us now, so we're getting some great views of the southern regions. At the start of summer, really, the southern polar cap was quite large, but it's now become summertime in the southern hemisphere of Mars, and that is sublimated away, and it doesn't do it evenly. It cracks up and breaks apart in different places. Been quite fascinating to watch.
That is fascinating, because you get features revealed, don't you, like the mountains of Mitchell and sort of various dark rifts across the southern polar cap.
You do, and they could be quite striking. We've also had some brilliant dust clouds and some bright morning and evening clouds on the Terminator. It's such a dynamic world, Mars. All the more appreciative of it since we only get it every 2 years.
Yeah, I know, and not always very good. I mean, this is going to be the best opposition of Mars, really, until, dare I say this, 2033.
Yes,
it won't have the same sort of size through the telescope again until that time. So you need to get out and observe it, really. It will be. It's strikingly bright, isn't it? I mean, it's brighter than Jupiter this month, which is saying something, and it's got that beautiful colour.
And it draws your eye straight towards it because that ochre red orange colour is so striking because there's nothing that bright and that colour in the night sky. You can't miss it. It's so shockingly obvious in the night sky.
Yeah.
And as you say, brighter than the planet Jupiter. The other reason, of course, this is a brilliant opposition for UK, Northern Hemisphere-based observers is it's actually quite high in the sky. The last opposition, where Mars was slightly larger at opposition, was very, very low from UK skies. This time it's really high in the sky, so we could get some really good views of the red planet.
And images as well. I mean, the big problem with a low planet is the seeing.
Yes.
And atmospheric dispersion, which spreads its colour, gives you a fringe of colour on the bottom and the top. And with Mars being so reasonably high in the sky, it's a real treat. We just haven't had that for such a long time in the UK.
No, we haven't. And of course, the red colour helps both imaging and visual observers, because the longer wavelengths of light are less disrupted by the poor seeing than the shorter wavelengths. So we've got every reason to enjoy this particular Mars opposition. It's going to be a very good one.
It will be, and it'll continue to be so through into the beginning of 2021, of course. We shouldn't give up on it.
No, that's right. If you've got an 8-inch telescope, you should be able to follow Mars quite easily all the way through down to January. If you've got a larger telescope, even longer. So we should be looking at Mars as a long-term winter opportunity here to observe and record all the dynamic changes that are going on in the Martian surface and the atmosphere during this time.
Okay, well, Mars isn't the only planet on view, of course, even though it's the best one. Although it isn't, is it? Quite well, it is. But we'll get to that in a second. But Jupiter and Saturn are both there, very visible, and of course they're very close to one another at the moment. They're actually we'll be starting to get very close as we go towards the end of the year. But they're so low down, aren't they? That's the problem.
They are. I mean, I've had some good views of Jupiter this year. Not that many, because the seeing, as you say, has been poor, but we have had some clearer, steadier moments. But it's such a shame, really, because there's so much to see on both planets. It's rather unfortunate they're both low down, but they are starting to climb up. Saturn is already notably higher, I think, this year than it has been in previous years.
Yeah, that is actually very good, and I have noticed that. And of course they will start to gradually eke up the sky over following years. And of course next year we have an equinox on Jupiter, when the planet is side onto the sun, basically, which is really quite exciting, because it means that the Galilean moons, which orbit in, or their orbital planes, are more or less aligned to the equatorial plane of Jupiter. They're not quite in alignment, but they're close enough. So that means they can interact with one another. So you can get them eclipsing one another, occulting one another. And another quite interesting effect, which I haven't seen before, but I believe there is one coming up in June of 2021, where you'll have one shadow passing across another on the disk.
I've heard of this. I've never seen the event myself, but it is quite exciting when the shadow of one Galilean moon is overcast on another Galilean moon. I think I've seen drawings of either Io in Europa's shadow or vice versa. It's quite a sight to see, but I've never seen it myself, so I'm looking forward to that.
Yeah, looking forward to that too. Okay, well, let's move out further to... Technically, it's the best placed planet, which is Uranus.
It is. I guess you're best to say it's of all the planets that are not brilliant naked eye objects. It is. Mars is the best placed planet for naked eye objects, but for non-naked eye objects, which really for most of us Uranus is, it's the next one. So it comes to opposition on the 31st of October in the constellation of Aries. Quite distinctive in a pair of binoculars. It does shine with this greenish hue, but you will need a telescope, I think, really, to see it as any sort of disk.
Can you see the colour in binoculars? I've only ever seen it as a sort of star-like point in binoculars with no colour. I need a telescope normally to actually pick out that colour. I
could tell it's not a white fleck of light. It's not white. I could tell there's something about it. In the finder scope, it does look slightly green. My telescope. I suspect that's because it's being held on a mount, and I'm not holding it freestyle with binoculars, and so that makes it easier to identify. But,
I guess so.
Yeah, I think to see it as a planet, you really do need a telescope.
Okay, well, Uranus, from the centre of the UK at least, gets up to an altitude of 51 degrees when it's due south. Compare that to Mars, which will get up to, I think it's about 43 degrees. That's not a huge difference, actually, is it?
No, it's not. But I fear Mars may steal the thunder during this time of year, being so well placed and so brilliant and easy to find.
Yeah, okay. Well, Neptune, the furthest main planet in the solar system, was at opposition last month, and that remains well placed for observation, but it's such a long way away. It's difficult to see much detail on its surface.
Yes, this is really where imaging comes into its own for planetary observation, because I think a number of amateurs, Anthony Wesley and co, have recorded some interesting storms on in the atmosphere of Neptune.
Yeah.
Something that, would have been impossible, really, even as much as 10 years ago. But we're now getting these good high-resolution images of the outer planets. But visually, it's very, very difficult. I've never seen anything on Neptune. It only ever really looks like a nice deep blue disk to me. I've never seen any surface features on it.
And should put a shout out for its brightest moon, Triton, largest moon, Triton, which is...
it's quite bright, actually, Triton.
It's surprisingly bright, isn't it? Yeah.
And easier than the moons of Uranus, which is a lot closer.
I know, it's incredible. So that's well worth going for, your furthest moon in the solar system. Okay, well, let's have a look at some of the special events which are happening. On the 1st, we've got a full moon, which, because it's the closest full moon to the northern hemisphere's autumn equinox, is the harvest moon for 2020.
Right.
And it's the first full moon of 2 which occur in October.
Yes, there's one at the start of October and one towards the end of October, so that can't happen that often, I'd have thought.
It's surprising, actually. They do fit in because the period is sufficient, so long as you get that first one in really early. If the month is long enough, you can't get that happening in February, but in the other months.
Yeah, I suppose if the months are long enough and it happens right at the start, a full moon happens at the start of the month, then you've got enough time left to get a second one.
And popular culture, of course, calls the second one, which occurs this month on the 31st, a blue moon, even though it's not the correct term at all. It's the third moon in a season of 4 normally. So it's a bit mixed up, that whole definition process. I think when you actually do apply the seasons being from solstice to equinox, from equinox to solstice, you don't actually get a blue moon at all at this time. But because it's 2 in 1 month, which is the popular way, the incorrect way, it will get called a blue moon.
Fair enough.
You don't sound convinced with that. Okay, so we have some other interesting things. It'll be well worth looking out for Mars, actually, which reaches magnitude minus 2.5 at the beginning of October, because it'll be really close to a virtually full moon. Of course, the moon will be at opposition at the same time that Mars is at opposition in that position. So that'll be pretty good.
We have some meteor showers, don't we, this month? We have the Draconid meteor shower, which reaches its peak, sadly, during daylight. But it's well worth looking out for this shower. This is on the 7th and 8th of October.
Yeah, that's right. There's actually there are 2 shouts out for 2 additional periods of interest predicted for the morning of the 7th at 01:25 UT and 01:57 UT. Very precise times, because they're going to be quite short bursts if they occur, so it's well worth looking out for that. I mean, it has to be said that Draconids is not a rich shower, but its peak zenithal hourly rate is about 10 metres per hour, but the enhancements have occurred in previous years which boost it up. And then, of course, we've got the Taurids as well. We've got on the 10th of October, the centre of the broad peak of the southern Taurid meteor shower occurs. Now that has a zenithal hourly rate of 5 meteors per hour, but the Taurids have been associated with fireball events in the past.
Yes, I've never had much luck with them myself, but I might make an extra special effort this year to go out and see them if the skies are clear, because it is a shower I'd like to follow. I do quite like the brilliant fireballs. They are very, very pretty, but they are quite rare, and I've only seen a couple of them.
Yeah, few and far between. Well, the other big shower, of course, this year is caused by bits of Halley's Comet vaporizing in the Earth's atmosphere, and that's the Orionid meteor shower, which actually reaches its peak in 2020 under favourable conditions on the night of the 20th of October and into the morning of the 21st of October, because the moon will be out of the way. So that'll be quite good, actually.
Yes, that's another meteor shower that can produce some nice, swift, very colourful meteors. I've had more luck with the Orionid meteor shower than any of the others, actually.
Oh, right,
so
okay.
I should definitely go out and see that. Speaking of the moon, there is another nice event that you've reminded me of on the 12th of October. This is the waning crescent moon, which will be visible in the morning sky. There's a good libration showing the impact basin known as the Mare Orientale, the Eastern Sea. Of course, when back in the day the Mare Orientale was charted, it was on the eastern limb of the moon. But when the IAU changed the orientation, the Mare Orientale now lies on the western limb. But it's nice. It's a very impressive impact feature. Lunar orbiter photos show it well, but it's something I've always wanted to see. And every time I've had a libration that's been pretty good, it's been cloudy. So I'm hoping this will be one that I could get where I can get a look at the Mare Orientale.
Yeah, well, let's keep fingers crossed for that. Okay, well, before we move on to the stars, it's just worth mentioning as well that on the 25th, British summertime comes to an end. Hooray! At 2 a.m. BST, which then becomes 1 a.m. UT. And then we're back to sensible time throughout the rest of the winter, or autumn-winter period. Okay, well, let's go out to the stars now then. So we've still got the stars of summer in force, really, early evening. We've got Cygnus the Swan, which is a large constellation occupying the northeast corner. Is that the best way to describe it? Or area of the summer triangle?
Yes. It hangs around for quite a long time, the summer triangle. In fact, the top part of it really is quite easily visible in winter, but I guess we might say it's not at its best. But still, a very nice distinctive constellation. The Swan's beak is marked by that beautiful binary star, or I should say double star, Albiro, which is really quite a beautiful sight in any telescope, I think.
Yeah, it is. And southeast of Albiro is the rather underwhelming constellation of Vulpecula the Fox, which is quite large. It sort of goes up underneath the... which side would it be? Well, the eastern side of Cygnus, but there's hardly anything there. And the actual constellation itself is just a couple of stars with a line joining them together when you look at it on charts.
Yeah, very difficult to make out of Fox, isn't it? There is one object of interest, of course, in Vulpecula, and that's M27, the Dumble Nebula, which is quite a bright object, actually. And even in a small telescope, it kind of looks like an eaten apple core. You could get this dumbbell shape from it. I've never seen the central star in it, though.
No, it is a very nice object. And also, of course, we shouldn't forget it's got Broca's cluster in there, which is it's got various names, Colander 399, or the coat hanger cluster. But it's not a cluster at all. It's actually an asterism, a chance alignment of stars in Vulpecula. You can see it with the naked eye. I've got good eyesight.
I've never actually looked out for it with the naked eye, but I find it very easy in binoculars or my 10 by 50 finder scope.
Okay. Well, Vulpecula marks the western end of a short line of small constellations, which includes Sagitta the Arrow, Delphinus the Dolphin, and your favourite constellation, Equuleus the Foal.
Why is it my favourite constellation?
I just made that up. But there's nothing, is there, in Equuleus? It's just a little quadrilateral of faint stars, and it has nothing to endear it at all.
No, there's nothing there.
Patrick used to talk about Aries and say, there's nothing in Aries at all. But Equuleus is worse. I mean, it's really small as well. It's quite one of the smallest constellations, a very strange little area of the sky.
It is. Sagitta does at least look like an arrow. And Delphinus, you can kind of imagine a dolphin there, I think, with some imagination.
Well, it's just the nose and the neck, isn't it?
Yeah. They do at least look like something like they're supposed to look like. But these are small, but they're next to another equine constellation, I suppose we might say, Pegasus the Flying Horse, which is quite a good constellation. It represents this mythical flying horse, but actual fact from the UK, the flying horse is upside down, isn't it?
Yeah, and you only get to see the torso of it, plus the head. In fact, the nose of the horse is quite close to Equuleus. That's marked by Epsilon Pegasi, or NF, which is actually the brightest star in the constellation of Pegasus. And of course, very close to NF is that beautiful globular cluster, Messier 15.
Yeah, it's actually quite a bright globular cluster, and it's worth spending quite a bit of time looking at it. It's one of those objects, the deep sky objects, that actually does rather well under high power. You can use, it's not like a planet where, if the seeing isn't quite good, you lose definition. Clusters in particular, globular clusters can do quite well under high power. And I've looked at this cluster through a range of telescopes, ranging from a 4.5-inch reflector right up to my current 12-inch reflector. And I have to say, each view I get through it with a different telescope, I notice more things in it. It's a very rewarding little globular.
Yeah, I agree. And of course, we've got the Great Square of Pegasus, which is that geometric asterism, which defines the horse's torso, if you like. And it's always a bit of an oddity. We always mention this, but it's only 3 of the stars in the Great Square of Pegasus actually belong to Pegasus, and none of the sides have equal length. But apart from that, it's a great square.
It's a great square with only 3 stars and 4 unequal sides. But yes. It's actually Alpheratz, isn't it, the one that's the odd one out, because that's part of Andromeda now.
That's right. That's the star which is in the northeast corner of the Great Square. It used to be Delta Pegasi. If I remember correctly, it was Syrah was the name of that.
I don't recall. You're probably right.
Yeah, okay. Well, the front legs are represented by a collection of relatively faint stars, which are immediately west of the Great Square. And if you head north from there, you find the zigzagging collection of stars, which depicts Lacerta the lizard. And I quite like Lacerta. I mean, it's quite faint, but if you take the time to actually locate it, there's a lovely little asterism in there, which I call the mini W, because it looks exactly like a sort of shrunk version of the W shape of Cassiopeia, the seated queen.
Right. I'll look out for that, Pete. I've never seen it myself. Actually, it's good. I think your garden is darker than mine, so you probably have more luck with these smaller, fainter constellations than I do. I don't think I've ever observed anything in Lacerta.
It's a strange thing, isn't it? Because you sort of you have to put quite a bit of effort in to actually see these things, and I think even as seasoned stargazers, you sort of look up at the sky, and there are areas of the sky which you deliberately avoid. You don't do it, well, actually, you don't do it deliberately, you do it subliminally.
There's nothing there, is there? So you don't really have any cause to visit them.
Or they're just difficult to make out. I mean, good examples are Camelopardalis, Aculeus, if you like, because there's not much there, and Lacerta. And Lacerta is actually quite a complex constellation, because there's quite a lot of stars in it, but it just a really faint and difficult to make out pattern. So you sort of take your time to not look at it. But if you do sort of work out where it would be, and things like the Great Square are good for this, because you look at it on a chart and you can work out how many steps to take to actually get to it. They can be quite rewarding.
They can, yes. I think you need a darker sky for it. You need an unobstructed horizon as well. That's the other thing.
Yeah.
Because a lot of these constellations can easily become lost in trees or rooftops. I suppose that's the other thing that makes them difficult to seek out.
Okay. Well, there's plenty, obviously, to see in the October night sky. Lots of obscure constellations to hunt down, but the real...
And the blue moon.
And the blue moon. But the real star of the show will be Mars, which will be incredible. And if you've never seen Mars before through a telescope, now is the time to try and get access to a telescope to look at it, because it will be pretty stunning.
Yeah, absolutely. I wish everyone clear skies, and I hope everyone gets some good views and some good images of Mars. Thanks, Pete.
Thanks, Paul.